Okay. Hi, everybody. Welcome to our first live presentation in several years now. My name is Alyssa. I am part of the team at Pikes Peak Mycological Society, and I'm happy to introduce James, our president, who you probably already know, and he has a presentation to give you. And it's just a very short informational thing for you. So without further ado, James, it's all yours.
Okay. Thanks, Alyssa. Thanks for getting us all set up.
My
Uh,
pleasure.
just shared my screen here. And so what I wanted to do was talk about a couple things we have coming up. So in the month of May, we have a lot of stuff going on, and we're hoping to do more of these webinars. We're hoping to do one a month throughout the season. This is a new thing that we're doing. This helps us get additional speakers, and then we're also partnered with the UCCS Mycological Society Club. There's a new club there. We're partnered with them, which is fantastic. They're providing lecture halls and then additional speakers. That's why we have more events. So given our weather conditions here on the Front Range, we're hoping that we can foray hopefully pretty soon. We're trying to figure out exactly when that date will be, but if you're not renewed, as far as your membership goes, you might want to renew so that way you get those emails and you know when we do foray. We don't always get to foray in the spring depending on the weather, but since we had that snowstorm and it looks like we might have a little more weather coming up this weekend, it should set us up. And so I wanted to throw that out there. So get your membership up to date. And if you're not a member, become a member for $30 today, and you will learn more than you ever thought about mushrooms. So the first event on the 1st is actually a UCCS event with Dr. John Fleming, MD, Ethics of Psychedelic Assisted Therapies. And that's at Centennial Hall number 203. That's the lecture hall that we've been in a couple times now. It's a fantastic spot, and we're really grateful to be able to utilize that. But this is their speaker, and they also have another one on the 3rd, which is going to be at the UCCS Kettle Creek Lodge. That's more on natural medicines in our communities, and that's with Lieutenant Sarko. And there's actually a first responder meetup before that, and then at 5 o'clock, 5 to 7, they'll be doing open to the public, and that's at the Kettle Creek Lodge. I'm not sure where that is on campus, but he was actually featured in the Michael Pollan movie, I believe. So those are exciting events. Our next event with PPMS will be with Melanie Kahn. She's the author of the book Mason Goes Mushrooming. She's fantastic. We're going to do a kids like art workshop of some kind at the Manitou Art Center. And so that will be more of a time when you bring the kids and you do fun stuff. And so that's still being planned, but we know it's going to be at Manitou Art Center on the 17th. And then we'll be doing another webinar next month with Mycota Lab, and they're offering free DNA sequencing for specimens in Colorado. They're doing several states this year, and Colorado is one of their targets. So we have the opportunity to get our stuff sequenced for free. We're going to take them up on that offer, and highly recommend that anyone who's into science and scientific collections get on board with that. The more that we can collect, the better. That tells us, what species we do have here. There are a lot that we don't know about, and a lot that are already named that do exist here that we haven't discovered. So that will explain how to do it, what the process is. It's fairly easy. You basically take pictures of your mushrooms, dry them, fill out a voucher or print a voucher, and then you send a piece off to Mycota Lab, and then they will DNA sequence it. And if it does get sequenced, they'll put that on your iNaturalist record. So it's a great way to contribute to community science. You don't have to be an expert to do it, and it helps a lot of other people. So that's our next event. Before we get going, I just wanted to mention a few spring mushrooms. Since they're out now, we are finding mushrooms, which is great. And we're happy about that. But I wanted to throw out kind of the things to look for, because a lot of people don't know where to look or what they're looking for. So one of the most common mushrooms we're finding right now is the cottonwood oyster mushroom. It grows on cottonwood. for the most part. It grows on other trees too, but for most of the time, 90% of the time, you'll find it on cottonwood logs and stumps, typically down in the riparian areas. It's pretty abundant. I found some a couple days ago, and it's, it fruits prolifically, and it's a great spring mushroom. It's one of the first ones we get, so it's pretty exciting. The next one, which should be popping up any time now, will be the pheasantback, or it's also known as dryad saddle. So this one's always on Siberian elm stumps. So if you know anywhere there's a bunch of elm trees cut down, stumps, look on those. That's where you're going to find it. It's often confused with the hawkswing or the sarcodon, but those are actually up higher in the mountains under spruce, and they grow on the ground, where these are always on wood. As you see here, this stump is fruiting a bunch of them all around here, and this was in Colorado Springs a couple years ago. The underside has pores rather than spines. It's also got a lighter brown color. So this is typically a spring mushroom. It can happen any time of the year, but this is one of the first mushrooms that seems to show up for us. It's also a great edible when it's young. If you slice it open, it smells like a watermelon rind or a cucumber. When it's older, more mature, it can be really tough, like almost like a piece of rubber. So it's important to find them when they're in the early stages. The next one is a new name, actually. We've always called this one Copernellus micaceus, and that's in all of your guides, but some recent DNA evidence supports that it's actually Copernellus saccharinus. I learned that a couple days ago, and that's most likely the most abundant variety we have in Colorado, but it's also possible that we have more than one. This one is always on dead stumps growing around it. In the city, you'll often find it in huge clusters of hundreds. And it's another edible mushroom. It's related to the alcohol inky and to the shaggy mane. I personally don't eat them, but they are edible and they're very abundant. Usually just have a lot of dirt, as you see on here. This one's a little dirty. This is the one that everyone wants to find, the blonde morel. This one will stump you for years. And they're pretty rare in Colorado, honestly, a lot of years because it's usually dry. But these they just started occurring now into May. So for the month of May, this is one of the mushrooms to look out for. You'll find these in the floodplains of rivers and streams all along the Front Range and also on the western slope. Anywhere you see cottonwood or large groves of cottonwood, that's a great place to look. And we're hopeful that we'll get to find some of these on our next foray, but it's hit or miss. And it's really easy to walk right past these and not even see one. I walk past them all the time, and people find them behind me. So you need to learn to slow down and look and really tune in. They camouflage really, really well, so that makes them even more fun. And a lot of people go out and can't find these for years, but the tips are be out there at the right time of year. So beginning of May is an excellent time, provided the weather's good. We just got a nice snowstorm, so the ground's pretty wet still, down deep, and hopefully it stays that way. And that sets us up for, morel foraging, which is one of the most sought after choice edible mushrooms in our state. And then after, later in May, you move up the mountain and, actually, I want to say one more thing about this one. So this guy is often under big cottonwood trees. So when you look at the cottonwoods, if you see younger ones, it's less likely, but the really big ones, especially as they die, if you see dead ones or ones that are half alive, that's where you really want to look. This guy starts coming up in May as well, and a lot of people don't think to go up at higher elevations, but this is more of a snowmelt morel. And so this can occur in both in burns and then also as a natural morel, where there are no forest burns, but it's typically between 8,000 and 9,000 feet. It's where the snow just melted. They can be very difficult to find at times, but the key is going at the right time of year, right after the snow melted. So the month of May is an excellent time. I'd say about 10 days into May or so, if you go up about 8,000, 9,000 feet, along streams on north-facing slopes, down at the bottom of valleys. Look for Douglas fir. They do prefer Douglas fir. There are other morels out too, like Morchella brunea, but Those are a little more sporadic. These usually, when they show, there will usually be a lot of them. And so they can be out right in the sun, but just look for dead trees, look for Douglas fir. And that's my tips for that. And it does work. So this is one of the ones that people really have a hard time locating. And usually it's because we're up in the mountains a little later than that. And we usually don't start getting up into those elevations looking for mushrooms until, June, July. So this is one that comes mid-May or so. And that's all I have. So I'm gonna probably turn it over here to Lauren. Dr. Lauren Czaplicki I met her in Telluride. I was processing scientific collections for the rare fungi foray with Dr. Amy Honan. And Lauren came walking through the hall and started talking to us. And she asked about presenting. And um, we definitely want to learn about mycoremediation and mycorestoration. And she's an expert in that. She went to school at Duke University, from what I understand. And I said, yes, we'll try to make a spot for you. And we have to do it probably in the new year because we were winding it down at that point. And so now we're lucky enough to have her, and we're really grateful for that. And really curious what she has to say. And I don't personally know a whole lot about micromediation, and we love the topic, and a lot of people are asking about it. So we're really happy to bring that to you. I'm gonna find a way for her to share her screen. So go ahead and take it over, Lauren. It's all you.
All right. Thank you so much.
Thank you.
Yeah. Share that. Okay. And then we're going to move this little thing over. Boop, boop, boop. Okay. So I love how James, you introduced the mushrooms, because that's not what I am like familiar with. That's not how I have accessed the mycological world. Um, but I love foraging. Down here we have white king boletes, um, and they're so tasty. Um, and I'm looking for morels.
Okay.
Yeah,
Well, you have your chance soon. I mean, you're in Durango, right?
yeah.
Yeah. So along the Animas River, you should have morels in the cottonwood down there. It's
Wow.
a, very good possibility. And there are a couple different ones that actually occur. We think there's only one blonde morel, but we've learned that there's a couple different ones. There's one that's a little more gray too.
Oh,
So now people are finding them today. Actually, I saw on Facebook someone posted some morels, but they're really small, so they're hard to find right now. And but they are starting, and depending on the moisture, I don't know if you guys got that storm, but we know that they're out. And if you wait like another week or two, then they'll be big enough to see them. A lot easier.
oh, nice. Yeah. So the morels are actually one of the examples of the ascomycetes that I found in my really, really, really polluted soils. So let's get into it. Thanks for having me. Um, Today I'm going to talk about microremediation and microrestoration. And I'm going to share stories of how we can leverage fungal allies to fix past mistakes, i.e. pollution and fire suppression, and minimize future climate challenges. And this is in 4 or 5 ways, with pollution cleanup, fire mitigation, water/wind erosion control, revegetation, and weed management. A little bit about me and my company. Um, I hold a doctorate, a master's, and a bachelor's focused on environmental engineering. And I did go to Duke for my graduate work. I worked at Duke University's Superfund Research Program, and there I coaxed native soil fungi to clean up legacy pollution from Superfund sites on the East Coast. Then I moved to Durango, Colorado, and we are in the middle of a forest that is really drought stressed. So I've added restoring the local water cycle to my list of problems to solve. And on fire mitigation, we're leveraging an intergenerational partnership with Jeff Ravage. And yeah, that's about me. So let's get into pollution cleanup. This is what I spent um, like about a decade of my life looking at and focusing on. So here, the problem comes from chemical spills. It comes from oil and gas extraction and mining, both hard rock and minerals, like rare earth minerals. Um, and that led to acid mine drainage, which ekes out more heavy metals from the rocks. And all of this leads to lots of toxins in our environment. And when we approach this using microremediation, we can group these problems into organic, aka carbon-based pollution, or inorganic, which are not carbon-based, and you have to do something else with them. So the organic ones are like chemical spills, oil, gas, diesels. The chemicals, the inorganics are like the fertilizer chemical spills and um, like nitrogen and things that aren't like attached to a carbon in their chemical structure. Then acid mine drainage is also in this category, as well as heavy metals and salts. And then with the carbon-based contaminants are also other hydrocarbons like creosote, polycyclic aromatic hydrocarbons, PCBs, dioxins. These are like the ones that all the buzz is about. But they're distinct from what you have to do to deal with mining legacies. So let's get into why. So it turns out that fleshy wood rot fungi are great for a lot of things, but not for cleaning up soils. And I've got that little turkey here. It was a turkey tail. So a lot of people want to use oyster mushrooms, or turkey tail, or other mushrooms for cleaning up soils. And Michigan State University, a couple researchers in the 80s or 90s, they did a bunch of work trying to get them to colonize soils. And it all failed. So I had to go back in time to the origin story for this to like really make sense of it. And this is the tale of the unrottable utility poles. So it was the 80s. People in the Southeast US wanted to protect their utility poles from fungal rotting. And so what they did is they just like went to, they created like this toxic sludge known as creosote, but it was mostly a mixture of like 36 plus different PAHs. And a lot of times they would incorporate other hazardous waste because they just wanted to make it as toxic as possible. And they slathered this on utility poles. And the utility companies thought they were doing so great. They were just very smug, and they thought they thwarted the fungi. And they were wrong. These utility poles rotted anyways. The fungi just said, "Oh, that's cute. You think you can thwart us? We don't really care." It wasn't just one fungus, or a couple. It was over 1,000 different fungi chowing down on these utility poles.
Wow.
Yeah. And they commissioned a group of scientists to look at fungi associated with decay in treated southern pine utility poles in the eastern United States. And they looked at 246 creosote and pentachlorophenol treated southern pine poles in service in the eastern United States. And white rot fungi were there. And people got really excited about that because we knew how to grow them because we grow them for mushrooms and we've had a long history of cultivating them. But what sort of got lost in all of our excitement was that there were also microfungi that were thriving in these utility poles that were supposedly super toxic. So I looked at the history of effort from the 1980s until now, well, until like 2013, which is when I started my PhD. And well, actually fall of 2012, regardless. It was a while ago. But it made it all the way to environmental engineering firms and they tried it. And then they just got fed up and said that it didn't work. So I looked at this paper and I saw what else within that broke down, and that was the microfungi. And I found this Nature Reviews paper by Harms et al., published in 2011. And it showed that it showed a bunch of different fungi. And down here is the group known as Basidiomycota. These are your wood rot fungi, your fleshy fungi, the edibles.
So your guild fungi there.
Yeah. But there's so many within the Ascomycota and within the basal fungal lineages that we don't really know much about. And they all can break down PAHs, which are what we were looking at. And I thought this was strange because they weren't just, living out in the soil. They were parasites of animals and fungi, parasites of insects. They were ectomycorrhizal symbionts. They lived in fresh water and wet soil. They were arbuscular mycorrhizal symbionts. And then they were saprobes and pathogens and symbiotes. These were not the typical wood rot fungi. And they didn't just have one ecological characteristic, like they didn't just have one lifestyle. So I kind of went back to basics and I thought about, well, how does fungal digestion work? So we've got our happy little oyster mushroom, and it produces spores that fall down and that germinate into mycelium. And this mycelium explores the food source or the environment that it's in. And as it's exploring, it's spewing clouds of enzymes that will hopefully, or, if from the perspective of the mushroom, these clouds of enzymes will encounter a wood piece and break it down, and then it'll absorb it through its skin or its little mycelium threads. And it turns out that that other fungi do that as well, like our blonde morel here. It produces mycelium and it also produces these enzymes as it explores its environment, looking for food, minerals, nutrients. And this similarity in how the fungal mycelium works, it unites them in their capacity, so in their breakdown capacity. So I was like, well, if introducing all these extra wood rot mushrooms didn't really work in the past, and we know fleshy fungi won't thrive in soils, and introducing fungi is hard. Let's see if fungi are already in the polluted soils already, and then let's use those. Because it doesn't really matter if they're macrofungi or if they're microfungi. They all can do the breakdown. And for this, to test this out, I worked with my group at Duke to sample some soils from the Holcomb Creosote Superfund site. And remember, this is carbon-based pollution. This is polycyclic aromatic hydrocarbons. So I sampled the super polluted soils, then I extracted DNA from them. I prepared it for sequencing. I sequenced it, and then I made a fungal map, like a kind of a yearbook of like who's who. And what I found was that despite increasing pollution, we still found many different kinds of fungi. So this is a map of Shannon diversity. Diversity, just you could use whatever metric you wanted, but Shannon was what I used. This you could imagine this is like number of different species. And then I sampled from 5 different increasing pollution levels. And at this top one, the soils were just oozing creosote. And then I looked within the whole species list, and I compared that with the increasing pollution level, and I saw which ones were sensitive, so which ones were less prevalent in higher polluted areas, and which ones were more prevalent in the higher pollution areas. Those were the resilient ones. And then I mapped them out. So our fungal who's who wound up finding more resilient fungi in the Ascomycota, which is this green clade, than in the Basidiomycota. And overall, we had more resilient fungi total, because it kind of makes sense, because if you think about it, these are ones that can withstand like a legacy of high pollution. All the other ones probably would have died out or disappeared. But I'd also like to call attention to these bold ones. Mucor, Rhodotorula, Cryptococcus, Minimedusa, Lentinus, Exophyla, Phylophora, Bisoclamus, Penicillium, Botrytis, Calototrichum, Fusarium. Those have been documented in the literature to have some degradation capacity. So next I wondered if these microfungi might need special food. Since they don't grow on wood, what else do they need? So I chose to play with trichoderma that I isolated from the site. And trichoderma has 3 lifestyles. It can grow on wood. It's quite happy on wood. It can grow on leaf litter in the bulk soil as a saprobe, or it can grow off of bug shells. And it's used as a myco pesticide because it eats the fungus that would eat our corn. So we know a lot about it because it's used commercially. And so we also know what like what genes are correlated to all of these. But basically, I set up these little vials with trichoderma, a model PAH, some nutrients, and different nutrients or different carbon sources, whether it's wood, cellulose to approximate leaf litter, or chitin to approximate bug shells. And I found that indeed special soil typical food promoted more pH breakdown than the like just throw wood chips out to feed them. Cellulose saw an increasing effect with the more cellulose you added, and chitin, a little bit of chitin goes a long way, it seems. So we actually tried the same treatments with real polluted soils, and we got 80% degradation across the board within a month. And these were really, really, really polluted soils. So the microremediation take-home lessons were to feed the fungi what they need and or are used to eating. To use local fungi, you can't take a like a silver bullet panacea approach to this because we tried that and it didn't work. The local fungi just fought them off and they couldn't really get a hold in the soils. And especially like here with our super dry environment, if you get a commercial strain from, I don't know, say Washington, and it's like used to like 70% humidity and like 60 degrees all year round, it's not going to have a good time when it's, when it sees the environmental conditions here. Like here we have the biggest like daily temperature swings. And we also have very little moisture. So you need to use fungi that are that are adapted to the local environment. And the more I look at this, the more I talk to other people, the permaculture folks, this looks a lot like gardening. So you add compost, you try to get the fungi like really, really happy. And fixing that is like fixing a soil for or like adding organic matter so that you have the ability to grow veggies or herbs. Local fungi like mediate all those processes in the garden. So it makes sense. So let's come back to what to do with the inorganics. And for a long time, I was just like, well, what can you do with inorganics? You can't break them down. With carbon-based pollution, you can theoretically like tear the carbons apart into water and carbon dioxide. Or you can break it down into some sort of fungal sugars that the fungi incorporate into their cells. But with inorganics, they're just metals. Like you can't do anything with them. So for a while there, I was like, well, you just can't do anything. We're made our mistake, and now we have to deal with the consequences. But there is a solution. We can leverage plant partnerships to stabilize metals in soils. So there are estimates of between 70 and 90% of land plants are mycorrhizal. They rely on fungi below ground to provide them with minerals, with access to deeper sources of water. And they they also can leverage them as protection and coping mechanisms for toxic metals. And in particular, the sunflower, which is native to most every biome in Colorado, except for, the high alpine um, and the desert. But I've seen these a lot in the San Luis Valley. Um, and also in Creed, where there's Creed, the whole town of Creed is basically um, on tailings.
Yeah.
So they have a lot of problems with heavy metals exposure.
Yeah, and I believe it's in the water supply too. My cousin actually grew up in Crete and lives there, and yeah, I don't want anything to do with the water there.
Yeah, yeah. The EPA came in and they coated a trough along the waterway so that it wasn't exposed. There wasn't like an interface between the soil and the water um, for a long time, but still, while it's like coming down and then percolating into the little stream, it's still a lot. But these sunflowers, they have this symbiosis with a fungus, with a couple fungi, that allow it to tolerate really, really high levels of cadmium, of lead, um, also I think nickel, without dying. And there were tests of this where they had two pots of sunflowers, one with the symbiont and one without, and the one without like keeled over. Um, it had its leaves were not the bright green, they were yellow, and it had a really hard time. And the other one with the symbiont was completely, it was fine. It might have been a little bit smaller than the others, but it was still like, thriving, and definitely alive. And so we can um, get them sort of concentrated from the soils up into the plant tissue. And then we can harvest this plant material and either put it in a landfill somewhere or incinerate it, or we can try and develop a protocol for recovering the metals to their um, industrial use. Um, so we can sort of mine them from the flowers themselves, um, rather than like creating new mines for lead and zinc.
So the sunflowers, the symbionts are able to take the metals up basically, and if you were to take the sunflower, the whole plant and remove it, you're removing the heavy metals, right? That's what you're
Mhm.
saying. That's
Yeah,
that's
yeah.
awesome.
And then others still, they can stabilize the metals in soils.
Hmm.
So the Glomeromycota, they all produce this sticky protein called glomalin, and it helps hold soils in structure so that it's like not just like one mass of sand or silt or dust, but it gives it its structure. And this can also um, grab onto metals. Um, so when you have a lot of plants, um, even if they're not like taking it up, they have these the Glomeromycota are arbuscular mycorrhizal fungi, and they support between 70 and 90%. The systematics people might be still arguing about that. Um, but yeah, so the chances are good that there's going to be a plant that you have that's native to your environment that is that has this fungal symbiont. And then by growing these plants, you can work that organic material into the soil, which also helps sequester the metals. And then also you have this glomalin in the soils in greater amounts. Okay, so now let's get into fire mitigation. And fire mitigation is really a combination of two problems. One, it's a small water cycle problem. So a lot of us are probably familiar with the large water cycle, the one where the water evaporates over the ocean, the jet stream brings it over the mountains, and then where it condenses and then flows into rivers, and then it returns to the ocean. But within that, there's a small water cycle where in the mountains, if a drop of rain falls, it will get uptaked again. And it'll, like, a single drop of water on average spends about 7 times going through the cycle before it joins the larger water cycle. And urbanizing regions without regard for this small water cycle it means that there's less trees, which produce less healthy soils, and less water overall stays locally. And so the small water cycle is responsible for about 60% of a region's moisture. And less local water means that there's more drought. And then when you add 100 years or so of fire suppression, we've got a recipe for high fire risk. And there's over 300,000 homes in Colorado alone that need fire mitigation. And it would be like billions of dollars to pay to rebuild these. And we do still need conventional fire mitigation work, but it thins evapotranspiration potential by removing a lot of trees, and it also destabilizes slopes. And logging equipment, it compresses soils, which initially I didn't quite grasp like how big of a deal soil compression is, but it's a huge deal because soil, if you have like a circle, like a pie chart of soil, it's half solid, quarter air, and a quarter water. And when you compress that soil, you don't have those pore spaces for air and water anymore. And this is why it's good practice to stay on trails and not go off trail very, very much. And when you're foraging, to not all follow one behind the other, but to kind of spread out and disperse your impact on the soil. But yeah, so logging equipment is this traditional fire mitigation is mechanical. So we bring all these really heavy equipment out into the forests and into the wildland-urban interface. And this compresses soils, which doesn't let them hold water. And the solution is to use native competitive fungi to upcycle dead trees and slash into wet soil in about 4 years. And this is where a little oyster mushroom can come in and be happy. With Jeff Ravage at the Coalition for the Upper South Platte. Now he's also advising, he's the chief scientific officer, I think, at MicroReach. We work together to supply this to the western slope, and on the Front Range, he's doing this with larger municipalities. So what we do is we first go on a mushroom hunt, and that's where y'all can help. And we find and test ideal strains to convert each forest-specific coarse fuel into soil. So we go out and we look at, well, what sort of slash are we dealing with? Out here, it's a lot of ponderosa pine. So what I did is I went out and I found some ponderosa pine that's rotting. And then I cloned that, and I'm going to send it to Jeff to grow up. And then he's going to send that back to me, where I add the fungi to the wood on site. And we can leave these soil moisture probes to make sure that they are actually performing well. Because here we've got about 70% of the snowpack that we usually have. So it's going to be a really a much drier year. So you want to make sure that like those moisture levels are high and the fungi are having a good time rotting those. And we dovetail into existing efforts because we come after the other ones like chop and drop, where they basically chop down a tree and then like leave it there, but that doesn't eliminate fire risk. It doesn't have the huge environmental impact of hauling it away, but it still is very expensive. And so chop and haul is where you'd chop it down and then you'd haul it away. And that does eliminate fire risk, but a lot of times you're having to haul it using a lot of heavy machinery, and you're having to haul it significant distances, and you're not being able to sell it for any real money. Like the best you can get is firewood, but even then you're basically losing money because diesel is so expensive and you have to bring it such great distances. And prescribed burns would be wonderful, but it's really hard to find a appropriate time to do it because it's pretty much fire season all year round. And it does eliminate fire risk when we can do prescribed burns, but it's not as if like if you make a slash pile, you can immediately burn it. A lot of times it takes a couple seasons to dry this sort of wood out, especially here with a lot of the pines and the firs. They've got that that sap, and so they hold on to water a lot longer. And in that time, we could rot them and they could be well on their way to becoming soil, and they could be actively holding on to more water on the landscape and helping our water infiltrate into the ground instead of just like washing off. So this brings me to water/wind erosion control. And this is a problem up in the Alpine. And only recently, this past summer, it came to my attention. And of course, there's a fungal solution because there's fungi are my hammer and everything is a nail. So the problem is that in our Alpine mountains, in the wintertime, there are dust events that deposit onto the snow. And this dust decreases the albedo in the snow, which leads to earlier snow melt and less water when it's useful and less water in general. Like the San Luis Valley, for example, is getting snowmelt like 3 to 4 weeks before they would usually. Um, and I think it might be, don't quote me on this, but um, I think it might be happening in April and May instead of later in the season when it's useful for irrigating their potato fields. Um, yeah. And this is because we have decided that every square inch of land needs to be cultivated or ranched or developed in some way. Um, and these activities in the arid West have busted the crust that's holding the soil in place. Um, so raise your hand if you have been hiking and you've seen these crusts. Um, they're like, yeah. Um, so they're, for those of you who might be tuning in online, um, these crusts are like sometimes they look like little mosses. Um, they tend to be dark in color, um, and be a little bumpy. Um, but they also extend around, just like mycelium. It tends to like fluff up a little bit in its older growth, but there's still like microscopic um, little mycelial threads extending around it. Um, it's sort of like that, but basically where you see basic like intact soil um, around these biological crusts, um, like that takes hundreds of years to grow. Um, and that and the perennial grasses, um, grazing got rid of those. And nothing so far has worked to restore these. Perennial grasses, like just taking time off, hasn't worked. Um, Letting them sort of lie fallow to naturally restore just hasn't worked. And saying it hasn't worked for the biocrusts is an understatement. Um, there have been a lot of researchers like working for years to try and grow the biological crusts back, and nothing really works. And what happens is these large empty spaces between, between the plants that are still there, um, that the cows and the sheep haven't grazed, they become runways for dust. And the solution for the early snowmelt is to install wood sponges in the subalpine and montane elevations, um, to let them sort of like to do this in the fall, so that they are underneath the snow melt, underneath the snow, and when we experience snow melt, the wood sponges will hold that in the system, and then they'll slowly release it over time. It'll sort of buy us a little more time. And then in the arid environments, we can break up this dust runway with the wood sponges too, using local fungi that probably aren't producing above ground fruiting bodies. But for illustrative purposes, I put a couple mushrooms in those. But yeah, when precipitation comes, it'll slow this water flow, also decreasing the erosive water power. Um, I heard my favorite definition of a desert recently. And it's not where there isn't water. A desert is when there's any precipitation, when there's water, it floods. And if you can slow the water flow, you can decrease the water power um, of that rain event. And that means less particles get deposited into the river, and then also less erosion compromises that soil structure. So there's less of a chance that it'll like blow away. And lastly, revegetation. So out here, we have a big problem with burn scar revegetation plans. They're not working. And that's because of the scale of these mega fires that we're getting lately. A lot of small fires might eventually recover, but these big ones that burn acres and acres and acres, like continuously hundreds of thousands of acres, they're so intense that they sort of sterilize the soil and really challenge that, um, like the spore bank within that soil. Whereas traditionally, we had more frequent but low intensity fires. And they would travel around the forest, leaving clumps of trees. And those clumps of trees came with the the little fungal spores and the propagules like around those trees. So they were sort of refugia for the fungi that can recover the soils. Um, so the solution for that is to borrow supporting fungi from nearby undisturbed soil. In situations where it's like hundreds of thousands of acres, this can be a really far distance. But it tends to work better than anything else. Um, and it's a lot more appropriate for conservative land management regimes. So, for example, our public lands, like the national forests and I think BLM managed lands, they don't allow any like non-native fungi to be brought in. But if you're enriching fungi from a nearby undisturbed soil or a native ecosystem, um, it's a lot easier to apply. Or you could, you could just collaborate with me and my supplier up in Paonia to make local compost rich with mycelia.
Nice.
Yeah, with mycorrhiza.
Have you used any of the burn foliotas for any of that? I know that there's like three different ones at least in Colorado anyway. If you go to any forest burn, the most abundant mushroom is the Foliota brunescens, I believe that's the one. But there's the Carbonicola group is what it's called, and they only show after a forest fire, and they do for many years um, in the soil. I would imagine that
Wow.
would be a good one. I don't
Yeah,
know.
that
That's
would
the
be
thing that it's the first thing that comes to mind when you were saying all that. I'm picturing all these Foliotas, just thousands of them all over the ground. You know what they're doing. They like that burn up soil, and then they're doing their
Mhm.
and bringing life back to the forest. I think.
Yeah, that's exactly what they're doing. So I have these, I found the a couple of morchellas in my creosote polluted soil. Um, and then I looked into what they do in forests. Um, and forest fires and creosote both share polycyclic aromatic hydrocarbons. Um, one's just naturally made. But because polycyclic aromatic hydrocarbons are also products of incomplete combustion, they're super prevalent in post-forest fire soils. Um, and because a lot of these other, these first responder fungi can break down those components, um, they have a selective advantage in that ecosystem over all of the others.
Mhm.
Um, and they make that soil more able to hold water because they break down those contaminants that are uh, hydrophobic or that repel water. So, um, if we can like source them locally, um, it would be so great. It would be just a leaps and bounds towards um, speeding that recovery of that forest.
Awesome. I think even after this, we should talk sometime about the different fungi that are in burns because I've been collecting those and studying them the past few years for
Oh,
sequencing. And I'm
yeah.
trying to get a list of all the ones that are burn fungi. I mean, we already know that there are papers on that and whatever, but in Colorado in particular. So I know we have at least three different burn foliotas. Um, Obviously, everyone's looking for burn morels, and that's
Yeah.
one reason to be out there. But there are tons of other burn fungi, and
Mhm.
I've just been making note of those, and may even make a presentation on it one day. But I'm really curious. I'm just curious, why are they there? What are they doing? How come it's always the same ones?
Mhm.
Um, and I think we have an idea of kind of what's going on, but I think if you had a list of those, maybe it'd be helpful in what you're doing
Yeah,
for restoration.
we could create a blend.
Hmm.
Um,
There should be a really good list in Sam Mitchell Herbarium. Vera and I worked on burn fungi for 4 or 5 years in a row. Let's see, this is probably some time ago now, but maybe from 2015 on. So I know there's a list of burn fungi and specimens up in Sam Mitchell Herbarium.
Hmm. But then you
nice.
could get a list of all the local ones that are in Colorado that, that would go with your
Yeah,
project.
James is right. There's 4 foliotas that are burn ones, and there's several ascomycetes, um, not just Geopixus carbonaria, but several other ones. That being the one that comes to my top of my head for burn stuff. But there's also gallerinas that come up after burns, and that's what we find a lot of. Uh, it has to do with the intensity of the burn also. If they make big piles like they did on Rampart Range Road, which is one of our prime destinations to look for fungi, those piles burn so intense that nothing grows there for the longest time after that. So
Mhm.
even though prescribed burns do help, if they're not conducted correctly, they're too hot, and
Oh yeah.
then those are big dead zones. Even the rock starts to melt. So I think once you got quartz able to melt, which is probably 4,000 degrees Fahrenheit,
Oh wow.
that's it for anything that's alive there for the next 10 years. And those spots can also be remediated with inoculated wood chips and then planting over the top of them.
Mhm. Yeah, I know we have at least three. The Foliotas is probably more, but there's Foliota brunescens, I believe is the main one. Then we have Foliota molesta and the common name for the common one that we found in New Mexico. I'm forgetting it right now. And then also an interesting thing that we found last year in New Mexico on a ridge, there was Crassosporium. So that's like usually the one that's found in the fire rings.
Oh.
We got up to the top of a ridge. I was with Alan Rockefeller, and we got up to the top of this ridge. It was super dry. We couldn't find anything, and we get up to 11,000 feet, and there are snowbanks in this burn, in the Luna burn. And right where the snowbanks are melted, there's just thousands of Crassоспorium at the top of that ridge. And so it was like a combo snowbank burn, mushroom. It was really the coolest thing. I'd never seen anything like it. I mean, because usually it's one or
Oh.
the other, but to see it in, both there, it was like it was a burn. We know there's specifically two burns, but the snow melt, there were like 2 or 3 foot, snow drifts up there that were providing the moisture for them.
Oh,
Really
yeah.
cool stuff. But there's a lot of them, and I'm sure that if you're making a mixture like that, it'd be good to include some of that. Or I'm not sure
Yeah.
what you're using now, but
We
there's a
had
ton of photos.
we had a couple questions from the viewers in
Yeah.
the chat. The first one he says, where they say they check for aluminum, barium, and strontium proven affecting bees, and wonder if in mushrooms from chemtrails, cloud seeding, or when they do lab work, can they detect that? Okay, sorry, I missed the whole half of the question. So when they do lab work, can they check for those metals and if it's affecting the bees and the mushrooms, I guess is the question.
Well, they can definitely detect them, if you ask them to.
Okay.
Um, Mushrooms hyperaccumulate metals.
Mhm.
So I guess if the bees are eating the mushrooms, they might be like hyperaccumulating those.
Well, they have an affinity for the mycelium, don't they? The bees.
Oh, I don't know.
Okay, I think that's what Paul Stamets. I learned that maybe from Paul Stamets.
Hmm.
Brian, do you know anything about that? Brian might have left. That's okay. Our next
He's
question.
he's on mute.
Oh. Well, our next question, maybe we can circle back to
There
that.
is, yes, they do go into the dirt and wood chips and work on eating mycelium. It's a
Oh.
question as to whether they're attracted to the mycelium or the moisture content in the mycelium. And this year is a weird year because there's no bees. I've done bee work all over the state so far this spring. I have a giant crab apple tree that hums in the spring with bees. Before you see them, you can hear them. No bees this year. On the western slope out in Glenwood Springs, no bees are happening. So I'm worried. And, bees have 6 feet. So they're insects. And that means if bees are getting it, other insects are dying off too. And we're just going to have to see. We think about bees because of their importance as pollinators.
Yeah.
So, and we don't think about the other insects, but it seems to go across the board that there's other insects in a mass extinction deal going on right now, and we'll just have to wait and see how that works. The phyto mining by using plants to suck up heavy metals is really cool. I'm familiar with it. And of course, the information I read was using it on gold tailings to try to extract gold. It's always us. We think
Yeah.
about us humans first before we think about the environment or earth or anything else. But that's really cool. And I didn't think about the part of phytomining where they have a mycorrhizal association with fungi. And so that was really critical. Thank you, Lauren, for that.
Yeah.
That's a very good point.
You're welcome, Brian. And overall, the take home here is that for micromediation to be successful, we need to use local fungi. And this is not a one size fits all. And that also challenges the research because it makes the lab-based research tough to apply broadly. So we need to do lots of little test plots. So yeah, if you have a problem site you are working on, I'd love to consult with you and yeah, reach out, either ask me a question here or email me at lauren@fungalsolutions.com.
There was one more pretty relevant question
Yeah.
about the plants, the sunflowers specifically.
Mhm.
How do you dispose of the sunflowers after they've done their work?
Yeah. So, how we currently do it, when we have soil pollution is to like excavate a whole area, like down to, I don't know, a foot, 2 feet. And we take all that material and we throw it in a landfill, but a special one, um, ha designated hazardous waste landfill. These are landfills that are like extra lined or whatever. But it's still putting it in a landfill. Um,
What about
with
burning?
with the sunflowers, we would put less material in the landfill. Um, we can incinerate it and have even less material. Like we can just put the ash in the landfill. Um, yeah, it's a tough call um, with these inorganic contaminants because anything other than recovering the metals for productive use is going to have some environmental impact.
Thank you for that answer. And thank
Thank
you
you
for
for
being
that
here too.
question.
Any other questions from our YouTube audience? Doesn't look like at the moment, but this will be streaming live now, but it will be recorded and saved forever on our YouTube channel. We want to thank Dr. Lauren for being here and everybody else for participating.
Yes,
And
thank you.
you can
Yeah,
reach
thank
her
you
at
so much.
email her at Lauren. I'd say your email address again? Lauren@fungalsolutions.com.
Yeah.
Or you can get in touch with us too at the Pikes Peak Mycological Society on Facebook or through our website at pikespeakmike.org. Thank you, everybody, for watching. Have a great
Thank
day.
you, Alyssa.
Thanks,
Thank
Brian.
you.
Thanks, everybody.
Well, thanks for having me.
We appreciate it very much.
Look forward to
Bye.
seeing you out at Telluride too.
For sure.
Yeah, that'll be fun.
And we can ask Paul those questions out there too. So
He'll
he's
be there.
supposed to come this year and we'll get to visit with him too, I'm sure.
Oh yeah, he actually inspired my whole fixation on this.
Very cool stuff. I know that Jeff has asked us to work on a project, collaborate up on Pikes Peak. We're waiting for our nonprofit status to come through, and then he'll supply a grant. And we'll be joining you and Jeff in future projects, I hope.
Yeah, I love that.
Very
Thank
cool.
you very much.
Thanks, guys.
Thank
Take care.
you.